Okay, so you're looking to really get a handle on something complex, but without getting totally lost in the weeds, right?
Yeah, you want those key insights, the things that make it all click.
Exactly.
Hmm.
Without feeling like you're just drowning in data. That's what we aim for here.
Hmm.
And today we're taking a pretty fascinating journey. We're exploring where the precise world of science, specifically quantum physics, kind of bumps up against some broader cultural ideas.
Things you might hear about consciousness or energy healing, maybe
Right.
even manifesting your goals using, well, quantum ideas.
Right. And we've pulled together a really interesting mix of sources for this deep dive.
Yeah, we have. There's scientific commentary, some pretty detailed skeptical discussions from online forums.
And perspectives from folks who are actually involved in what gets called quantum mysticism.
Exactly. And the goal isn't to just, dismiss anything outright.
No, not at all.
It's really to dig into the core concepts, see where things align, and maybe more importantly, where the understandings really diverge.
Yeah. Our mission here is basically to clarify the actual science of quantum physics first. Get that baseline.
Then look at how the language, the terms, and ideas get borrowed or adapted.
Right, in those spiritual or self-help contexts.
Hmm.
And ultimately, try to spot where misunderstandings or maybe misapplications might be happening.
But doing it respectfully, acknowledging the different views out there.
Definitely. Okay, so where should we start? Maybe with the language itself. That seems fundamental.
I think that's a great place to start. Because what's really striking is how certain words from physics, quantum, obviously, but also energy, vibration, frequency,
They pop up everywhere.
they really do. And they've sort of branched out and are often used very differently outside of science.
How so?
Well, in quantum mysticism, they're often used quite loosely, almost metaphorically, you could say.
Which is totally different from how they're used in a physics lab.
Absolutely. In physics, these terms have very specific, carefully defined meanings. It kind of highlights this human tendency, maybe, to want a universal language for understanding things. Like energy means everything.
Right. But applying it everywhere without the scientific rigor,
Hmm.
well, it can create a kind of false sense of understanding.
Yeah, I get that.
Yeah.
Like Deepak Chopra, for instance. We found that piece where he actually admitted something interesting.
What was that?
He said his use of quantum theory when talking about consciousness was, in his words, a metaphor. He compared a thought to something indivisible, like an electron or photon.
Okay, but
But, as the interviewer pointed out, that's just not how quantum theory works. It's like saying, I don't know, happiness is made of music. It sounds nice, but it's not literal science.
right, it evokes something, but it doesn't describe the mechanics. And we see that pattern with other terms too.
Like energy.
Exactly.
Mm.
Online, you see critiques, like from Professor Dave explains, pointing out how energy is sometimes used almost like a synonym for, well, magic.
Some kind of undefined force.
Yeah, an undefined force that can do things. But scientifically, energy is the capacity to do work. It's about causing change in a physical system. It's a property of something.
Precisely. Not some, like, free-floating mystical substance you can just direct.
Okay. And what about vibration and frequency? Those get used a lot too.
They do, and Professor Dave makes the same point there, often used without any clear physical reference. In science, they mean specific measurable things like light waves or sound waves.
But in these other contexts,
It often seems to imply some kind of subtle, maybe spiritual quality, but without a real link to the physics definitions. So for you listening, the takeaway here is
language matters.
a lot. It really does. And this imprecise use, this borrowing and redefining, it can really blur the lines.
Between established science and maybe more speculative ideas.
Exactly. It can lead to real misunderstandings if it's not clear when something's a metaphor versus a scientific claim.
Okay, so that's the language piece, really important.
Yeah.
Now, building on that, let's talk about consciousness, because that's a huge part of this whole quantum mysticism discussion.
Oh, absolutely. This is where it gets really fascinating and maybe contentious. There's this idea present in some, let's say, non-mainstream interpretations of quantum physics, and definitely central to quantum mysticism.
That consciousness isn't just a bystander.
Right, that it plays a fundamental role in actually shaping reality. You might even hear that, quote, often attributed to Max Planck.
One of the founders of quantum theory.
Yeah, I regard consciousness as fundamental, which sounds like strong support for the idea that our minds actively participate in creating the physical world.
Okay, but how does that square with the sort of standard scientific view?
Well, the mainstream scientific perspective is quite different. Most physicists would say that the vast majority of things happening in the
Like
universe.
stars forming or chemical reactions?
Exactly. Galaxies colliding light years away, the processes inside our own bodies, they happen completely independently of whether a human is observing them.
Right. The universe was doing its thing long before we showed up to watch.
Precisely. Which brings us to that experiment you mentioned earlier.
The double slit experiment. Yeah, this one comes up constantly in these discussions. What's the actual science there?
So, the double slit experiment is genuinely mind bending. It's a beautiful demonstration of wave particle duality.
The idea that tiny things like electrons can act like both waves and particles.
Mhm. Before you measure it, the electron is sort of in multiple possibilities at once superposition. But the common leap made in some
Is
circles,
that us looking at it, our consciousness, is what makes it choose to be a particle?
that's the popular misinterpretation, yeah. But the observer effect in quantum mechanics isn't about human consciousness in that mystical sense.
So what is the observation then? What's actually happening?
It's about physical interaction. To observe the electron's path, you have to interact with it, usually with something like a photon of light.
And that interaction changes things.
It inevitably disturbs the system. That's what causes the wave-like behavior, the interference pattern, to disappear, not the fact that a conscious person is watching. It's a physical measurement process.
Okay, so it's the measuring device interacting, not the mind itself.
Exactly. It's a consequence of wave-particle duality and the uncertainty principle, as explained in resources like Schrodinger's cat. It happens whether a person is aware or not.
Got it. And speaking of Schrodinger's cat,
Mm.
that famous thought experiment,
Yeah.
how does that fit in?
Oh, the poor cat. Well, Schrodinger designed it to show how weird superposition would be if scaled up from the quantum world. The cat in the box with the radioactive trigger.
Is it alive or dead before we look?
According to some interpretations, it's in a superposition, both alive and dead, until the box is opened. Now, the resource we looked at makes a useful distinction between what they call quantum nonsense, the mystical idea that our consciousness collapses the superposition and decides the cat's fate,
Right.
and quantum common sense, which is the standard physics view. In that view, the cat's fate is determined by the physical event, the radioactive decay or lack thereof.
Yeah.
Our observation just reveals what already happened.
So opening the box doesn't create the outcome, it just shows us what it was.
Precisely. So while quantum mechanics is incredibly strange, the idea that human consciousness is required to make quantum events definite just isn't supported by the scientific consensus.
Okay, that clarifies a lot about the whole observation thing. So let's shift gears slightly. What about applying these ideas to things like energy healing
Hmm.
or manifesting desires?
Right. This is where we often see a really big leap from the actual science into, well, much more speculative territory.
These claims are definitely out there, energy healing methods using quantum principles to manifest what you want.
Very widespread in popular culture, self-help circles.
So scientifically speaking, what's the verdict? We talked about the definition of energy already.
Yes, and it's worth hitting that again. Energy scientifically is the capacity to do work, a property of physical systems.
Not magic pixie dust.
Huh, exactly. As Professor Dave explains, it's not some mystical substance or life force you can just manipulate for healing or making things appear.
So concepts like chi or prana.
Important concepts in certain traditions, absolutely. But science hasn't identified them as distinct physical forces that can be, channeled for healing in the way that's often described. Waving crystals around doesn't have a known scientific mechanism for altering health at a molecular level.
But some people genuinely report feeling better after these treatments. What could explain that?
The placebo effect is a major factor here. It's incredibly powerful.
Believing something will help actually makes you feel better.
Yes, your belief can trigger real physiological changes that alleviate symptoms. As discussed online, the placebo effect is real and can be significant. But crucially, it generally addresses symptoms, not the underlying cause of a disease, like a bacterial infection or a genetic condition.
Right, and what about manifesting? The idea that consciousness creates reality through quantum stuff.
Professor Dave tackles this one too. He basically frames it as a misapplication of scientific ideas. It's more like a self-help narrative using quantum buzzwords.
Appealing, though. The idea you have that direct control.
Oh, incredibly appealing, mind over matter. But scientifically, there's just no evidence that our thoughts alone can directly manipulate quantum fields to produce specific, tangible results in the outside world.
Which leads to a really interesting question. If the science isn't really there for many of these claims, why are these quantum mysticism ideas so popular? And are there downsides?
That's a great question. There are definitely reasons for the appeal. They can offer a powerful sense of agency, right?
Yeah, feeling like you have more control over your life, your health.
Exactly, more than maybe a purely materialistic worldview seems to offer. And they tap into that deep human desire for meaning, for connection, a sense that there's more to reality than just the physical stuff we see.
And the weirdness of quantum physics itself kind of helps.
I think so. It's so counterintuitive, so strange, that it almost feels like it leaves room for non-material or spiritual interpretations. It challenges our everyday assumptions about reality.
It makes a lot of sense. But what about the potential problems? You mentioned downsides.
Yeah, there are some real concerns raised in the sources we looked at. Financial exploitation is one.
People selling expensive workshops or products based on these ideas.
Right. As highlighted online and by Professor Dave, people can spend a lot of money on things promising quantum results, often with little actual benefit beyond perhaps a placebo effect.
And what about misinformation, especially health-related?
That's probably the more serious concern. Promoting unproven quantum health advice could potentially lead people to reject or delay evidence-based medical treatments.
Yeah, we saw some pretty strong warnings about that online. Some people even compared it to cult-like dynamics.
Yes, those more critical views are out there and important to acknowledge, but for balance,
We also saw comments from people who felt these ideas genuinely helped them.
exactly. Some individuals reported really positive life changes or experiences they attributed to these beliefs, even if the scientific explanation is debatable or, points towards psychological effects. We saw examples of people feeling saved by these approaches.
So it's complicated. Potential perceived upsides, but also definite risks.
Very much so. Which brings us back to the importance of, well, knowing your stuff.
Scientific literacy, critical thinking.
Absolutely vital. Having even a basic grasp of scientific concepts helps you sort through these claims.
To tell the difference between solid science and maybe pseudoscience.
Right. It lets you evaluate things more clearly, beyond just persuasive language or emotional appeal. You need that evidence-based reasoning.
So it's about being skeptical, but in a healthy way.
A healthy skepticism, yes. Not dismissing everything, but asking for evidence. And while science is always evolving, that doesn't mean anything goes.
Yeah, just because we don't know everything doesn't mean current claims based on misinterpretations are valid.
Exactly. The current scientific consensus, as reflected in multiple sources, doesn't support the core claims of quantum mysticism. It's generally viewed within science as pseudoscience or quackery.
Okay, let's try and wrap this up. Pull together the main threads for everyone listening.
Okay, so the big picture. Quantum physics. Amazing, complex, revolutionary for understanding reality at its smallest scales.
Oh.
But its concepts often get misinterpreted, misused, stretched way beyond the science in what's called quantum mysticism.
And that desire to link science and spirituality, it's understandable.
Totally understandable, and it has a long history. But it's just crucial, absolutely crucial, to keep the distinction clear between using terms metaphorically and making literal scientific claims about how the universe works.
So exploring these ideas is fine, maybe even interesting.
Sure, intellectually stimulating.
But you need to keep that critical filter on.
Exactly. Our goal here was just to shed some light, offer different perspectives, respect your curiosity, but without, endorsing ideas that don't have solid scientific backing.
Right. So maybe a final thought to leave you with. Consider this. We humans, we tend to look for simple, empowering answers, especially for really big, complex questions.
Mm-hmm. It's natural.
So how can we best use our critical thinking skills to navigate this complex world of information and belief, especially when it touches on something as fascinating but also easily misunderstood as quantum physics?
Yeah, keep exploring the actual science from reliable sources. It's mind-blowing enough on its own.
Definitely. And just stay discerning about claims that try to blend that science with beliefs that haven't really passed the test of evidence.